Let's continue to the module system. So the module system, or Lmod. Here we will look at the module system and what it is. The module system is used to access most of the software on Kebnekaise. We should also try out some of the commands for the module system, how to find and list software modules, load and unload them, and we'll also learn about compiler toolchains. So most of the programs, the software that's installed at Kebnekaise and indeed at most of the systems in Sweden is handled by something called the module system. And modules are used to set up your environment, that is paths to executables, libraries, etc. for using a particular set of software packages. It helps you manage the Linux shell environment, and groups of related environment variable settings can be made or removed dynamically. This is a way also to have multiple versions of a program or package available by just loading or unloading the module. These modules are generally installed hierarchically, at least at SPC2N. That means some modules are only available after you have loaded a specific compiler and or an MPI version, which were used to compile this software. So some useful commands. Lmod is simply the type of module system that we have. To see which modules exist, you would use the command module spider. So if I type module spider here, I get a list of all the software. And it will be a very long list. So let's quit it with Q. You can also write it short with ML spider. So module can generally be shortened to ML. If you are looking for something specific, you could say module spider and then, for instance, Python. Then if there is Python installed, and there is, it will list the versions of Python that are there. If you want to know how you load it, then you would say module spider the software slash the version. So let's see Python 3.11.5. Then it tells you in order to load Python, then you first need to load GCC core. I will say that when it suggests me to load GCC core, I usually say just load GCC, because often you will need the rest of the GCC package also when you are loading something else afterwards. So I usually just say load GCC. So what I would do then is I would say module load and then GCC and the version, which was 13.2.0, and then a space, and then Python /3.11.5. When you do that, you can say module list and see what you have loaded. Modules that are depending only on what is currently loaded, you can see with module avail, like that. So if you have loaded, for instance, GCC, there will be a lot of more things available than were before you loaded that. If you want to see modules that are loaded, you do module list or ML. And you load a module as I showed you, module load and the name of the module. And usually you should always give the version, because maybe we change the default version and then what you have no longer runs in the same way perhaps. To remove a module, you can do module unload. I will just do like this, clear, so I get up further on the page, and then I will say module list. Okay. But you can see what is here. And let's say I wanted to unload Python. I do that with module unload Python 3.11.5. Then when I say module list, then only the GCC is left. And I could also just do ml and minus the name of the module. If I want more information about a module, then I can do modules show. And then it tells me what is going to happen if I load this module, which paths will be set, what other modules will be loaded, and things like this. And if I want to remove all modules except those that are considered sticky, then I say module purge. Then ML shows me only 2 modules are left, and that are the so-called sticky modules, and you don't unload them except when using force also. Those are modules that need to be there because they are some environment variables and other things that are set up for the system to work correctly. So don't force unload those, but they will stay there as long as you don't do anything else. uh, yes, we are currently in the process of upgrading the nodes to Linux Ubuntu 24.04. At the same time, the modules and module versions will be synchronized, so it will be the same ones on all the nodes, which haven't been the case. The Skylake nodes have for long had old versions of modules, and that will no longer be the case. It also means that there will be a lot fewer versions. So old software not used and old module versions that are considered old will go away. If you need them, you can ask for them. We may or may not agree to install them, or may not be able to install them because sometimes they are simply old and incompatible. But yeah, the modules will be newer as we get everything synchronized. Okay, so let's try do some code alongs and do this in a terminal, either with a regular SSH as I'm doing here, or within ThinLink as I showed you earlier. So here in ThinLink, applications, system tools, mate terminal. Okay. So first, here I check which versions exist of Python, and that is what I already did, but please go ahead and do the same thing. So I will just do it again. Module, spider. I should do clear so I get up further on the page. Module, spider, Python. And then I wanted to check how do I load a specific Python. Module, spider, the version I'm interested in, like this. I also get told that it provides the following extensions, which isn't very much because most of the Python packages are in a number of other modules like SciPy bundle, and there's a Python bundle also which contains together most of the Python packages. Anyway, we saw now that to load Python 3.11.5, you load GCC or GCC core first. So let's first try and do module list. We see that there's nothing loaded except the sticky modules. Then we do module load GCC and 13 to 0. Let's do module list. And now it has that loaded. There's actually one thing that when you load modules, you can either load all of them on one line or you can load them one by one. But it's of course important that the prerequisites are loaded first. Now, when I already loaded a prerequisite, it actually means that if I just type Python and then tab uh, Python slash, and then it will autocomplete the only available version. So this can be an easy way of seeing what software is available with something specific loaded. We now have all of this loaded. And let's try to purge. It all goes away like that. Yeah, and as I said, several module loads on same line or one at a time, but loaded in order. And yes, compatible modules depend on the version, can be easily found if you have already loaded a version of, for instance, GCC. There is also a Kebnekaise AMD login node, which I mentioned briefly earlier. And now I would suggest you simply log into that. And you can easily do it if you have a terminal window on Kebnekaise. You just do SSH Kebnekaise minus AMD. And then try do the same thing and see which Python versions are available there and if it's different to what was available on the regular login node. Previously, there was a lot of differences. Now, I don't think very many, because previously the login node was a Skylake node, and the AMD login node was an AMD node, of course. So I will try and log in, and you can do the same. I am now logged into Kebnekaise AMD, and let's do ML Spider Python. And I think this is more or less the same ones that were available on the login node because they have now been synchronized. So everything would work the same. So I will just exit. Then I will talk about compiler toolchains. Compiler toolchains, they are bundles of software that you load that make a complete environment for compiling or using specifically pre-built software. Usually they contain at least a compiler suite like ECC or Intel, and then often they also contain MPI, BLAS, LAPACK, ScalarPack, fast Fourier transformations, and sometimes CUDA. That is actually no longer the case. CUDA is loaded separately. And some of the currently available toolchains, you use MLAV for versions and full updated list, because those are always loadable as the first thing. So we could say MLAV, and then we get a long list of the things that you can load without loading anything else. And as you can see, it's mainly compilers and so-called compiler toolchains, but also a few other things. So GCC is just GCC. FOSS is something that you would often load if you're doing compiling, because FOSS also contains OpenMPI, OpenBLAS, LAPACK, fast Fourier transformations, and ScalarPack. So that is very often the recommended thing to load. There is also Intel, and that contains Intel compilers, Intel MPI, and Intel MKL, and so on. But you can take a look at the list as it is currently with MLAV when you haven't loaded anything else. Let's take a look at FOSS and see what is available. So let's do ML spider FOSS. And we see that there are several versions of FOSS available. from 2021B up to 2025B. So let's try and load, for instance, 2023B. It's nice in the middle. And since it's available directly here, we can load it immediately. So we'll just say ml fos 2023B. ML is also short for module load. ML is also module list. And let's see what it loaded. Well, it loaded GCC core here and GCC. It loaded OpenMPI. It loaded OpenBLAS and FlexiBLAS, fast Fourier transforms, both regular and for MPI. And it loaded ScalarPack. So we got a lot of things loaded here. So the key point here is that we have now seen that software on Kebnekaise mostly is accessed through the module system. Modules are arranged hierarchically. Many modules have prerequisites that you need to load first. And then a list of some of the most important commands to the module system. Compiler toolchains are modules containing compiler suites and various libraries. We have a lot of more information on our documentation pages about this.